All right. So I hope you can still see my screen anyways.
Yes, sir.
Oh, so as I was saying that I say it's most practically common among researchers or students. They will have a good introduction, a good literature review, but when you get to the methodology aspect and then when they begin to talk about their data analysis plan, you just see them write maybe like 4 or 5 lines. They write something like, oh, we'll do a descriptive analysis. And then you see them writing, we'll do a bivariate analysis, or at times they will try and write chi-square. Then you just see them, they write, then we'll do multivariate or multivariate. Yeah, multivariate analysis. But well, as beautiful as that is, that's not just the end of it. For you to do or know the kind of statistical methods to use, something is very germane. You need to be clear about your objectives or your hypothesis, as the case may be. You need to know the type of variables you have or the data you have. I mentioned in the last class that the kind of data you have will determine the type of analysis you will do. So, and then in such a way, I will introduce to us tonight, and then we'll do the XPSS aspect. And then this is just to teach us, some of the basics. And the truth is, I can't teach all, in this class. It's something we can build on, and then you begin to explore on your own, as the case, maybe. So this is just the title. This is just the selection of appropriate statistical method for data analysis. The subtitle is a guide to choosing the right techniques. So as you know, my name is Oluwaseun Samuel Williams, and today's date. So importance of selecting the right statistical method. Choosing an appropriate statistical method ensures that you have a very good and accurate analysis. Not just that you have a accurate analysis, you can have a conclusions that is valid and that your result is very reliable. This helps in making decisions and enhance the credibility of your research findings. And then the correct statistical method will improve the accuracy of data interpretation, because when you have chosen the right method, when the right method have been chosen, it will help you to do the right in analysis, interpretation, and then it prevents misleading results. And this helps in supporting evidence-based decision-making in research, business, and policy formulation. Am I still sharing the screen, please?
Yes, sir.
Yes, sir.
Great. So you need to first understand your data. I said in the last class that we have different types of data. We have the categorical, we have the numerical. The categorical is qualitative, it could be nominal, it could be ordinal. These are some of the things I explained in the last class. If you by chance missed the last class, you can do well to check out the video. I've shared the link and I will still update the link. We have the numerical, which is quantitative, it could be continuous and it could be discrete. I'll be giving examples of when you have a categorical data. And the nominal data they are categories without a specific order. The example is the blood type. We have blood type A, B, AB, and O. The gender could be male or female and order, as the case may be. But as far as this country is concerned, we know that we have female. Some call it sex. It will be male and female. Your marital status could be that you are single. It could be that you are married. You could be divorced. You could be cohabiting. You could be, cohabiting or separated, as some will call it. And then the ordinal data, they are categories with a meaningful order, but differences between them are not uniform. They are categories, they have a meaningful order, but differences that exist between them. Example is your educational level. When you have your educational level, you have the primary, the secondary, the tertiary. Some even say, PG, that postgraduate. The level of pain, your pain. These are some of the things I also said in the last class. It could be mild, it could be moderate. You could have a severe pain. Your customer satisfaction, it could be that you are satisfying your customer poorly, it is fairly, is good, and then you are giving them an excellent service. The numerical, which is a quantitative, could be continuous or discrete. Continuous data can take any value within a range and can be measured with this. The blood pressure, even the temperature as well. The discrete data, they consist of distinct countable values, that is, they are whole numbers. The scale of measurement could be nominal, ordinal, or even an interval or ratio. Examples is the number of children, the number of hospital visits. As I said in the last class, that it's not possible to have a number of hospital visits to be 5.5. It's going to be a whole number that is countable. Either it's 6 days, or 6 times in a year, or 7 times in a year, or 20 times in a year. The number of cars in a parking lot, you can't have another car. It's either the car is old, countable, 10, 15, 20, 30, 40, 100. So the nominal scales, they are categorical, no order. Same example for the blood type, the eye color, the marital status. Same thing for ordinal scale. The same thing for the interval scale too. As I mentioned, the 2 types of data, they are interwoven in the type of scale. So the ratio scale too, these are the types of the ratio scale. There are some key considerations, as I said when I started, in choosing a statistical method. Your research objectives or research questions and objectives, the types of data, the number of variables, the distribution of your data, and the sample size. The size of your sample or the size.
What happened was
the sample size will determine. All right, thank you. The sample size too will determine the type of analysis you will do. Just imagine that you have a small sample size and then you're trying to do a regression analysis. Just imagine that you have a sample size of as low as 10, and then someone will come and meet you that I want to do a regression analysis. I want to predict. What do you want to predict with a size of 10? It's too minute.
If I see your hand in your mouth, there is no food for you tonight. If I see your hands in your mouth this night, there is no food for you.
Please kindly mute. Thank you. So now, as I started with XPSS, you have descriptive analysis. What you do in your descriptive analysis is summarize and describe data methods. Some example is the mean, median, and the mode, the standard deviation, the range, the variance, the frequencies tables, and then some graphical representations. If you are in doubt or you are lost, you can check week 1 and week 2 videos. It will help you. So the differential statistics. Differential statistics helps you to make conclusion. That is, it helps you to make decision. So what you can do from this is you can make predictions or you test your hypothesis. We have different types. We have when you have a categorical data, you make use of chi-square test or the Fisher exact test. And when your data is normally distributed, you use the t-test and the ANOVA. If you want to make use of the non-parametric, you make use of the Mann-Whitney U-test, the Kruskal-Wallis test, as I said in the last class as well. And then the parametric test, the non-parametric test, these are some of the examples. The parametric, the one with ANOVA, the non-parametric, and then regression and correlation analysis. What do you use correlation analysis for? Correlation analysis is just to test the strength of the relationship. You know, in such a case, when you have between 0 and 3, you can say that such a relationship is weak. When you have between above maybe 4 and 6, you can say that such, a relationship is strong. And then when you have 6 to 9, you can say such a relationship is very strong. And then when you have, 9 to 1, such relationship is extremely strong. And then 1 is a positive relationship. So which means the relationship of your correlation ranges between positive 0 to 1 or negative 0 to 1. Then we have different types of regression. Which regression can be used to predict? You have the simple linear, you have multiple regression, and you have your logistics. Your simple linear regression uses when you have a continuous variable or a continuous outcome. Outcome is also the same thing as independent variable. When you have logistics, it could be a binary logistics when you have a categorical. Then when you have advanced statistical method, you can use your survival analysis, a time to event, when you have data that has to do with time to. I think someone is really disturbing our class. Let me try and mute everyone. Sorry, I'm trying to mute everyone, please. Okay. Okay. Okay, so I think I've been able to mute all now. Thank you. I believe we are still together. You can just drop your comments. So when you want to do an advance, you use time to event, Kaplan-Meier curve, cost regression. That's when you have a data that is followed up over time, a longitudinal data or a data that is followed up over time. And then you do principal component analysis, use it to reduce, the number of variables or the variables you are interested in using. And then we have different types of, say, machine learning methods where you do artificial neural networks, your decision trees, your random forex, and then you do your sensitivity and specificity analysis. Now, this is a flowchart that will help you to select the type of analysis you want to do. Let's say, for instance, if your data type is categorical in the sense that you have gender, male, female, you have an health outcome like hypertension. Is that the person is, if hypertension is present, yes or no, or if the person is hypertensive, yes or no. You use your chi-square, Fisher-Isaac test. If the data type is numerical and is highly distributed, you make use of t-tests. You have the independent t-test. We have the pair t-test. I prepared a note on some of these. Maybe I can share with us on the group. When you have more than 2 groups, you use ANOVA. The full meaning of ANOVA is analysis of variance. If not normally distributed, that's when you make use of all these non-parametric tests here. You want to check the relationship between variables and is a continuous, use correlation, either Pearson or Spearman. If you now want to do a predictive modeling, you use of regression, it could be a linear regression or a logistics regression. Don't forget to make use of logistics regression when you have a categorical data. You make use of binary when it is dichotomous, just 2 out. Is either a yes or a no, 0 or 1. So that is that. So now comparison table for parametric and the non-parametric test. See some of the assumptions and some of the things that must be fulfilled before you can carry out any of these tests. And then one way to test, there are different ways to test for normality. You could construct your histogram with the curve. You could use a different test, maybe Shapley-Wilk test, or different types of tests to really know if your data is normally distributed. We have the parametric test, the non-parametric test. Assumptions. When your distribution is normally distributed, use the non-parametric tests. When it is not, you use non-parametric. The type of data, continuous. This could be ordinal or categorical. Examples, the t-test, the ANOVA regression. These are the examples, yes. Sensitivity, more powerful, his assumption is met, and here is less powerful but robust. Conclusion, and these things must be taken into cognizance. What do you do? Importance of choosing the right method for valid conclusions. Consider the data characteristics, your research objectives, and I said when we started too, and your assumptions. But anytime if you are in doubt, if you are not a statistician, you can consult a statistician or read more on this, or you can also consult me. So now, little practical using SPSS. And in our next class, then we can, in a way, move to, we can move to, R. I said R. That was a mistake. Sorry. Theta rather. R is not in the scope of this. Okay. So I will try and I think I have an SPSS data opened. Okay. Let's see this. Okay. So this is a data, and then we'll be trying. Let's try and see a correlation analysis first. This is just for the purpose of practicing. Let's see if there is any correlation between age and then the grade level. So this is our SPSS. This data has been opened already, and it's no longer. This should not be new to us again. How to open a data on the SPSS. I don't think that should be new at all to us. That shouldn't be new. So let's say analyze. Let's start from compare means, or let's say if you want to do a correlation, correlate by variate. Let's check for age and grade, level grade. So you can see it's showing Pearson, Kendall, Spearman. These are options. You want to see the mean, you click on it, but I'm not really interested in that. The style, the way you want it to present your result, you can put that. If you want it to even report confidence, interval, you can do that. So I'm using two-tail. Let me see what I will have. You can see that there's a negative correlation between age and the level of appointment or the grade in appointment. We have a correlation of minus 0.087. You can see it here. So this is a negative correlation between it. And then the level of significance is, this is what you have reported here, 0.125. Why the sample size is 312. Let's try for another one. That's how to do your correlation. So correlate, bivariate, different types of correlation which you are interested in. This is the bivariate. You can, check at your convenience and try to read more. Let's check age and cholesterol. Let me do okay. You can see here that it's also a negative correlation, and then negative correlation of 0.015. So you can play around, depending on what you are interested in. As I said earlier, your objectives. I do not have objectives for this. Okay, let me check. With I wouldn't know what this average is. I wouldn't know. I think, let me see what we have there. This is also a negative. This is also a negative correlation. So you can as well try as many variables as you are interested in, depending on what you want to do. Now, let me take us through. I think I have a document I wrote, or I prepared a little. Let me take us through it a little bit so that can help us when we start doing. I'm coming. Sorry. Okay, so I was just playing around. We went to use different statistical tests. Maybe I'll flesh this up and share with us. Let's say you want to do a one sample t-test. You want to compare the mean of a single group to a known or hypothesized population mean. Let's say, for instance, testing if the average blood pressure of a sample of patients differs from the national average of 120, or checking if student average test is not different from the national average score of 70. That's when you use one sample t-test. Let's say, let me come back to our SPSS. I hope you can still see the screen, please. Just drop comments. Let's say I click analyze. This is to check. You click on compare means. Compare means. Let's say, for instance, some of us that have done research before, if you click on this means, what this will just give you is to give you means across both the dependent and your independent variable. For instance, we show the mean and the standard deviation. Let's say age, and then sex. See options. Mean, number of cases, the standard deviation. Those are the things I've clicked on. You can click as many things as possible. You can click on the group mean. You can check the variance. You can check the kurtosis. You can check the skewness. You can even. But for this is what I just want to see. Let me press continue. And then I'll press OK. See the results. What it has done is that it has divided male, female. For the age here is a continuous variable. If age was categorical, for each categories of the group, the mean and the standard deviation for the age. But this time around, just for instance, if you want to find the distribution of your mean and your standard deviation in terms of the sex, and then which is in terms of the sex and then the age being the continuous for those that are researchers. In that case, which means you have the mean for the to be 30.83. And then the standard deviation to be 5 points, not category, for the age which is continuous. Let me look for the case when I wouldn't know if we have for the case when age is actually a descriptive. I said descriptive, sorry. Age is categorical. Let me see if there are categories for age. Okay, I think we have. Let me select here. So let me remove this. So okay. I'm not sure. Okay, this is for age that is analyzed. I'm coming. Compare means. Okay. Let's see what we have. Just trying to play around it as well. Age, where is our age? Coming. Remove this. Let me put the first age here, then the second age. Because this is showing the layer 1 and the layer 2. Let me put age R1 here for the second layer. Okay, let's see what we are. So you can see now, it has reported for the age that is categorical. See, so that is that if you just want to check the mean and then the standard deviation. Let's say, for instance, now I want to check for a one sample t-test. These are the test variables. What I just need to just put is put all the variables of interest. Age, let me put, let's say, cholesterol. Then I will check my options, whatever I'm interested in. Let's say continue. Then you press OK. So this is the age, the sample t-test. See, it's even giving us both the upper and the lower. The upper and the lower boundary for the confidence interval. This is it for when each time you do a t-test, because this is one sample, it's giving us the age. This is significant, less than 0.01. This is for the cholesterol, less than 0.01. And then on the table, if you are a researcher, what you will report, you report the mean, report the standard deviation for these two variables, and then you report the significant, and then you will report the significance too. And if you're interested in reporting the confidence interval, you will report that as well. And if you are in doubt as a researcher, you can just check some journals to see how you can report some of these things. And let's say we want to do an analysis for the case when we have a compare means. You want to do an independent t-test. An independent t-test. Let's check when we use an independent t-test again so that we won't be at any point in time confused. For here, I have a document. Independent. You use it to compare the means of two independent groups that are not related. That is, they are independent. Comparing the average cholesterol levels between smokers and non-smokers. Okay, for this time around, let's check the average cholesterol level between between male and female. Let's just check, for this case. All right. Okay, we have here. Let's see, analyze. Compare means independent. Sorry, compare means independent. Let's say the test variable, the cholesterol. Let's say sex. I wouldn't know if this sex is. So options, define groups. Okay, group 1, group 2, continue. So options. So you select your options as you deem fit, and then you click OK. So it has done for that. You can see here, it has reported your mean and the standard deviation for each sex category. And then here is showing equal variances assumed, equal, so it's showing the significant. And it's even showing the mean here to the mean difference and then the standard deviation. If you notice, if it's assuming equal variances, mean equal variances, is reporting for the different categories of that. And then let's say, for instance, you want to test for another one. Let's say, okay, I'm not interested in cholesterol, I'm interested in triglyceride. I'll click this, and then we have okay. It has reported this to start. This is the syntax, as I rightly said in the previous class. This is the syntax, and then you have the group statistics, you have the mean, and you have the standard deviation. You have for equal variances, and then for unequal variances. Let's say you want to check again. For an independent sample t-test, you want to check the mean difference between triglyceride and maybe the marital status, or let's see for age. I think there is a part of the age that is categorized. So it has, see, for the age 20 to 29, 30 to 39, the mean difference, the level of significance, and all that has been reported. This is the level of the confidence interval, 95% C high. Or let's say, for instance, okay, can you hear me now? Some can hear me. Okay, analyze. Compare means independent sample. I can just play around this. Let's check for hypertension. Let's check for hypertension here. And then let's see how age affects hypertension. Let's see how age affects hypertension. You can see the mean. It's showing the relationship or the mean difference between the age and then hypertension. One thing is, if you want to do a paired, it's quite unfortunate. We may not be able to do a paired because I don't have a data that speaks to a before and after. I don't have such data. But analyze. Let's check the compare means. You see, I have paired samples. This is for the paired samples. This is more like a summary of this independent sample. The paired sample, we have the one we ANOVA. This one speaks to the proportion. So depending on the type of data you have, let me show us something here so that can in a way help us. See, when do you do a paired sample? You compare means from the same group measured at two different time points. Let's say before and after. Let's say you want to check the scores of students before they started the program and after the program, and you want to see the impact. I don't have such data here, I would have loved to, use that. And then, so we'll use a one-way ANOVA. You compare the means of more than two independent groups, comparing the average blood pressure across different groups, e.g., age, elderly, or you want to test diet. I will do well to share this document with us, but let me just see how we can, go around that, and then you will see analyze, compare means, one way ANOVA. Compare means one way ANOVA. So you have the dependent list, you have the factor. Let's use I wouldn't know. Let me look for hypertension. So factor, let's say age. Okay, let me see. I'm coming. Let me check this first. Post hoc. So if you want to check the equivariances, you can click on whichever one you are interested in here. This is LSD. This is LSD. This is the different types. Turkey. Sorry, a moment, please. Someone is disrupting the call. Let me just end that. Sorry. Okay, so thank you. So dependent list, let's look for, okay, let's try this. Let's see what we have. Okay, see, between groups and within groups, this is one way and over. You can see this is 0.04, it's still significant. So you are trying to check the mean difference between age and hypertension. You can decide to, come in, let's check this out. This is one way and over. So if, for instance, you want to change your dependent list to the age, and then your factor to the hypertension, depending on, where is hypertension? Hypertension, dependent list, let's say age. Let's check as many sex. So let's check, okay. So you see, it's giving us for that of the sex and that of the age. You can see here, and, you are checking the relationship between age, hypertension, between the sex and hypertension. So this is mean square. This is the F statistics. This is the p-value or the level of significance. This is the p-value of the level or the level of significance. This is the sum of the squares. Some of these things can be obtained numerically. This one is this difference. For instance, now, I think this age here has two categories. So how to get the difference is n minus 1. Same thing here, which I think the sex here is just 311. 311 minus 1 will give us here that 312 minus 1, or removing 1 from it will give us that. So this is how, this was actually obtained or gotten. So one other thing you can do is, depending on the type of analysis you want to do, or depending on the type of data you have at hand, that's going to inform null hypothesis and your alternative hypothesis. I think that should not be strange to us. You have a null hypothesis and you have your null hypothesis is the same thing as your H naught. Your alternative hypothesis is the same thing as your H. On what you are working on. Maybe there's no difference between age and hypertension. So this, and you reject null hypothesis when your p-value is less than alpha. Otherwise, do not reject. This is your p-value here. You have to be 0.05. So what you do here in this case, your p-value is 0.4. Is it less than your? So you take decision, or you make decision based on this. So for instance, we want to try to compare the means in one way and this is age, sex. Let's remove this. Let's say it's HDL, and then we put the service yes also there. We put this age. Let's put as many. Let's see what we are. Okay, let's try this other one. Let's see. Okay. You can see. You can see this is the significance. Only sex in this case is significant. So in this case, you reject your null hypothesis since it's less than alpha. Others you do not reject because it is not less than alpha, and then you conclude based on your hypothesis that you have. Let's check, for example, that you have you want to analyze. Let's look for our normal regression in this case. Regression. Let's say linear regression. We have your dependent and your independent. Let's say your dependent variable is hypertension, the continuous part. No, let's use cholesterol, the one that has not been categorized. You call me? I wouldn't know if I have cholesterol that has not been categorized. But where in that case, if I can't see, okay, yeah, cholesterol that is a continuous, is a dependent. Then let's use age as continuous here. Sex is a categorical variable, as we all know. So let's try age that is now categorical too with it. Service here categorized, if I'm correct. Let's see BMI too. Then you come to options. You can check, okay, I'm not interested in any of this. If you're interested in any, you click, but I'm not. Star. Now selector variable, you can come and then let's say I want to use BMI as a selector variable. There's a rule. Okay, I've selected that already, so it's not going to work for that. So next, if I have two blocks, which I don't, so I would select okay. This is for a linear regression, and in this case, it is multiple linear regression. We have 6, we have age, we have service year, and then we have, this is the constant. You don't report constant, but you report this. So if you want to interpret this, is going to give you the ANOVA 2 for a regression. We want to interpret this. I think we did a cholesterol. We say we use the this is the unstandardized, this is standardized beta. Let's say we want to use the this is the coefficient, which is the standard error. We say for every unit increase in age, or let's say for every unit increase of 0.07 in age, there's going to be a negative decrease in cholesterol because this is negative. And then you say for every unit increase in sex, which is 0.14, or you say a unit increase of 0.4143 in sex will lead to a decrease, or sorry, a unit increase in sex will lead to a decrease of 0.143 in cholesterol. Whenever you have negative, it will affect the interpretation of your dependent variable. Whenever you have positive too, it will affect the interpretation of your dependent variable. Let's say, for instance, this one that is positive. For every unit increase in age, you have a unit increase of 0.03 in cholesterol. So every time you have a negative, it affects your dependent. Every time you have a positive, it also affects your dependent, variable. Let's say, for instance, now I want to analyze compare me. In this case, if you notice, we haven't tested or we didn't check even if our our dependent variable is normally distributed or not. We are just doing analysis. Let's say I want to check regression, a linear regression. Let me say I even want plots. I can click plots. This is a scatter plot. Let me say I'm interested in the dependents. You click which one is your Y and whichever one is the adjusted residual. If you want it to be your X, and you want your normal probability plot, you please continue, then okay. To give you plots, see. This is nearly normally different because it's very close to the middle, our dependent variable. It's very close. It's ready. I'm looking for let me see if I can include the Instagram plot that will help more to speak to this regression. Sorry. This is for modeling. I'm not interested in modeling. Please analyze regression, linear, then plots. I want to select histogram as well. You will see the curve. It will show the curve of the probability. See, in fact, this is normally distributed. Our cholesterol is normally distributed, which means the type of test we should perform on it is a parametric test. You can decide to test for any variable of interest or your dependent variable of interest when you are doing your analysis to know if it is normally distributed or not. So this shows, this plot here, you can see, this is perfect. And then you can see the distribution, how it is. This is normally distributed. Even this is showing that it's nearly perfect. You can see that they are all distributed closely to the middle. So that is that. We do not really have a serious outlier. If you have outlier, it will be showing, outlier shows that the values are apart. So let's try this out as well. Regression, linear. Let's remove cholesterol. Let's try HDL. And let's try the same thing we've been doing. Okay. You see, even the HDL2 is normally almost nearly distributed. Normally distributed. Excuse me, please. You can see the plots. Try for as many as you want. And one thing that is germane in analysis is that you must see that the type of analysis you want to do, that your data or your variable meets the assumptions. If the assumptions are violated, you may want to try another type of analysis. So let's see triglyceride. Let's press OK. Same thing for triglyceride as well. So, excuse me, please. So that is that for the regression analysis. One thing is very important. You have to practice a lot on your own. You have to practice a lot on your own. Let's see. I think I've tried correlation before. And let me just scroll to the correlation and try to interpret it a way that we will understand. Can I still find it? Okay, if I can't, let me try another one. Analyze, correlate, bivariate. Let me try cholesterol and age. So this is negative correlation. So it shows that there exists a weekly relationship because it's quite weak. This is 0.01. Let's say 0.02. Let's say between age and cholesterol, there is a weak relationship, a negative weak relationship between age and cholesterol. That explains that, because I think I saw on the chart that how can we interpret that? How can we interpret that? So that is that. Also, let's try some other things. Let's analyze. I think I've done t-tests. We've done correlation. We've done regression. Let's see logistics regression. Let's see logistics regression. And as I said earlier, we use logistics regression when your outcome variable is categorical. What do I mean by your outcome variable? Your independent variable is categorical. But this time around, we're doing binary logistics regression. You use binary from the word binary, just to 0 and 1. 0 and 1. Use binary. So let's say regression. Then you have here, you have linear, you have binary, you have multinomial. Different types of regression, you can try them out. Let's say we want to do binary. Let me remove all this. Let's say our dependent variable is, let's try BMI. I wouldn't know how BMI is categorized, but I think it's true. Let's try it. And then let's pick as many. I think this sex here is categorical too, but cholesterol here is continuous. And then we have some of the cholesterol here that are categorical. This HGL has been categorized, if I'm correct. Then service in here is categorized. Let's pick age. Categorized. Now, before I proceed, in logistics regressions, if you check some, binary logistics regression, multivariate regression, as the case may be, if you are a researcher that have been reading journals, you will see some will report crude odds ratio or unadjusted odds. See some will report adjusted odds ratio. Well, it's quite simple. It's called unadjusted or crude odds ratio when you are just regressing or you are checking the relationship between just an outcome variable and a single independent variable. A single independent variable in the sense that, let's say we want to check the relationship between hypertension and just sex alone. Such way you are selecting one. But in the case whereby you have as many as possible, let's say, let me put all of this out now. Let's say it's just relationship between BMI and age. In that case, what you are going to have is called crude odds ratio or unadjusted odds ratio. Let me use age, that is categorical. Sorry. So you click that. Sorry, please, excuse me. You click categorical to specify because this age is categorical. There's an indicator here. The indicator allows you to change. You can click here. Indicator, reference category. It speaks to, is either you pick the last or the first. Let me change the first. The first in the sense that we have different age categories, maybe age 16 to 20. Let me just do that so that we can see that first. Let me press OK. In this case, we have age R1, 2, 3. The other age that is not showing here has been used as the category, the reference category. That is the part you are seeing here. Let me try it again so that we will understand better. Analyze, regression, binary logistics, then categorical. Select. Let me change it to first this time around. First. Then continue. By the time you will notice in the results, you will notice that there's going to be a change. See. R112. You can check with the previous. Okay, it's still the same result. Let me change this time around. I think the last time I didn't change. Analyze, regression. Binary logistics. This thing did not change you. First, continue. Think okay. Let's see now. 3.15. As a result, change. Okay, I think it has. So, to interpret this, we have BMI, which is our outcome variable. We now have age. I wouldn't know what age one is. What you now say is that, let's say the category of this age is 40 to 45. It's just an example. Let's say 40 to 45. what you'll be doing in that case is this expected beta, this is beta. This expected beta is called the odds ratio in logistics regression, binary logistics regression. This expected beta, if it is theta, theta will report it as odds ratio, but in SPSS, it will not be reported as odds ratio. This is called expected beta. To get this beta, you can just do the exponential. It will give you what you have here. It will give you now. This is 1 point something. So to interpret this, you will just say that those in this age category, let's say age 15 to something, are 1 times as likely to be obese or belong to this category. Let me use another one, for example, so that you will not be confused. This particular trying to tell us that those in this age category, they have the probability. If I want to use probability, I will use probability, but I'm not using probability in this sense. I will say they are 1 time as likely to have this outcome compared to this age category. If I'm interpreting for these two, I will say that those in this category are 0.63 less likely to have the outcome, which is the BMI. Let's say, for instance, the outcome is hypertension. You say that those in this age category, they are 0.63 less likely to be hypertensive if it's hypertension compared to this age category, which is the reference category. I'll use another example so that we'll understand better. Let me do that. Regression. Binary. Let me look for hypertension. This time around, do I have hypertension? Oh, I don't have. Okay. Let's say cholesterol. Let me remove this. Don't forget, this particular one we are still doing is just for the crude odds ratio. Now, this is extreme because it could be that there is multiclonarity, so it's quite extreme. Let's do regression, binary logistics. Age. Let's see. Okay, I've seen hypertension, finally. So age, R1. So, okay. Now, this is it. If you notice, here is showing that we have hypertension, is that it is normal or elevated, that is, the person is hypertensive. This is our outcome variable or our independent variable. For this case, we use our outcome variable. Let's say the age R1 here is 15 to 65. I think the value label was not defined. Let me check under the value label, the age. Under the values, rather. Let me check for the age. Age, okay, age R1. Okay. So let's take note of this. Let me have the record here with me so that it will help us to interpret. For those that are in the first category, they are between 20 to 29. For those in the second category, 30 to 39. For those in the third category, 40 to 49. In the fourth, 50 to 59. Okay, that is okay. Come here. Now, we have 1, 2, 3, 4. We use the last category, which is 50 to 59 years, as the reference category. That's why we are not having the beta and then the odds ratio, which is expected odds ratio. If I want my analysis to have the confidence interval, there's a way I can go about it, and then it will surely have the confidence interval reported. and I will still click on that option, and then we will see. So now, to interpret, this is the outcome, which is hypertension. We'll say that for the respondent age between 30 to 39, this is 1.9. Let's, in a way, okay, they are 1.9 more likely or as likely to be hypertensive or to have hypertension as compared to those between age 20 to 29. I mean, sorry, 20 to 29 is not our reference category. The reference category is 4, which is 50 to 59. I will come again. Let's say this is a data on women. Let's say women between ages 30 to 39. This is R1. This is 20 to 29. Women between ages 20 to 29 are 1.9 more likely, or you say as likely, to be hypertensive or to have hypertension, which is the outcome variable, compared to those between 50 to 59. Now, for this same, you come here, you say that women between 30 to 39, which is for this age category, 30 to 39 are 1.6 times, or let's say 1.7 times more likely, or you say 1.6 as likely. Let's stick to 1. Let's say 1.6 times more likely to have the outcome, which is hypertension, to be hypertensive or to have hypertension as compared to those between the age 50 to 59. You will now come here again. You say that this is age 40 to 49. You say that women between the age 40 to 49 are 1.9 more likely to have hypertension as compared to those between age 50 to 59. I don't know if you understand that. If you don't, please drop a chat so that I can come again. If you can hear me, if you are following, just say I'm following. Now, this is reporting for the unadjusted odd ratio or whose odds ratio. And then let me, in a way, put the confidence interval rather as well, so that we will understand that. Okay, thank you for following. Analyze. Binary logistics. Sorry, why is it? Yeah. Let me put options. Now, if you wanted to have confidence interval, just click on this. See high for expected beta. Don't forget your expected beta is your odds ratio. If you are just regressing one dependent variable with one independent variable, one outcome variable with one independent variable. If you are pulling them together, if you're having as many and then you are adjusting, you have your adjusted odds ratio. This is continue. Okay. You will see here that it has reported the confidence interval. Can you see? So you report that, appropriately. Let's say you now have for analyze, you want to do for multi variables, regression, logistics. In this case, you put as many. Let's put collect. Let's put BMI. You put service, yes. Cholesterol. Then categorical. Don't forget, you must specify those variables that are categorical. If not, continuous variable. Continue. Then you have OK. See the output here. These ones are the reference category. The ones without values, reference category. Don't forget I said constant, you don't report constant. This cholesterol has just 2 categories, so it has reported. Then you report or you interpret just the same as I used earlier. You interpret. Now, let's say, for instance, analyze regression, binary logistics. Okay. Let's say you did not specify here. If you notice, I didn't specify BMI to be categorical, and then it treated this as what? As a continuous variable C. But if I had specified, it was going to show it as categorical variable. So you do not specify it to be a categorical variable. SPSS, or it will be treated as a continuous variable automatically. So you have to take cognizance of that, and it is very important that you really take note of that. You really take note of that. Now, let's say for instance now, let me remove this. Let me use this BMI that is categorized, and then I refuse to specify. Let me just press OK. See, it treated it. See, it treated it as a continuous variable. But let's go back, analyze, regression, binary logistics, automatically. Now let me go and categorical, specify that is a categorical variable. Continue. Okay. See, BMI this time around, it's showing us the other one. There are just 2 categories for BMI, so it's not going to show the other reference category, but it's showing that another category has been treated as a reference category. So that is that on that. So if you have like 3 or 4 categories, that's when it should be showing the reference category as the case. So I think that is well, explained. Now, if you can see the confidence interval, one thing is germane. If you are reporting in journals, or you are trying to write a manuscript or a research, paper, some research papers, a good number of research papers will say you report confidence interval. They will not want you to report this significance. How do you know if it is significant? It is simple. If your confidence interval, if the range doesn't contain 1, it is significant. Now, let's check. This is 0.3, 0.7. It contains 1. There is 1 within the range. This is, and if you check with the significant values to the p-value, you will notice that it's not significant. Don't forget this expected value. This is going to be adjusted or ratio because we have put, or we have adjusted for other variables. We have more than just 1 independent variable. If you notice here is 0.341 to 0.7. This is 0.321 to 0.7. It contains 1. This is 0.27 to 0. This is 10. It contains 1. Now let's see this. This is significant. It doesn't contain 1 because it's greater than 1. That's why you have 0.04. This is 1.03. It's greater than 1. This one does not even cross 1 at all. For this, it crosses 1. This is between 0.4 to 1.25. So such is not significant. Let's scroll up to for the ones we've done earlier. You compare the significance with the confidence interval. You can see for here, this ranges between 0.351 to, I believe you can see hear me, please. If you can see hear me, let's know in the comment section, please. Okay, can you hear me? Are you following, please? From here, you can see that it crosses 1. It's not significant. It crosses 1, not significant. This is greater than 1. It doesn't contain 1, so it's significant. This still contains 1, not significant. This doesn't cross 1. It's very significant. This doesn't crosses 1. It's very significant, and then same thing as this. So let's say you want to, I think this is for hypertension, right? You will say that those in this service here, 1, let me use 1, for example. This is 1.1, is 1.4 for more likely to have the outcome to be hypertensive as compared to this service here group. Same thing from age. Those in this age category 3, I think age category 3 is 50 to 59. I can't remember now. Yeah. 1.7 times more likely to have the outcome, which is hypertension, as compared to this. So that is that on that. So that is quite easy. And, to really grow your knowledge on this, it's advisable you read, try to check as, many materials as possible. This is what you may need to build on yourself. I can't teach all in this class. I can't teach all. I can only expose us to it, and then we'll see how well, you can, build on these things on your own, and see how well you can be well, grounded. I think I would like to stop here tonight so that, I can as well attend to other things. And if you have questions, feel free to ask. I will, unmute us now. Questions. I think most times when we ask questions, it helps us a lot. And in a way, some of the things maybe I didn't really touch, we can and see how well to go. So please, questions, feel free to unmute. So you can unmute, ask your questions if you have questions, please. Questions, or there's no question? Oh, okay. Well, I guess there's no question. Questions? Or we still want to digest, and then, when I share the video, we ask the question in our next class. Hello? Can we hear me? Just let me know if you can hear me, please.
Yes, sir.
Oh, okay.
Yes, sir, we can hear you.
Yes, sir.
Okay.
Yes, sir. We can hear you.
Really understand? Hello? So I would do well to, share the video, and then, we can prepare for service, those that have to go to church. And then we have a nice day. But don't forget, some things may be statistically significant, clinically significant. That's just one thing you put at the back of your mind too, as far as some analyses are concerned, So have a nice day. Thank you.